Have you ever wondered how the information gets between your computer's keyboard and your favorite website or program like Google, Facebook, or Microsoft Word? How when you push an A key on your computer's keyboard, how it knows to put an A on your screen? Today we're going to take a trip together inside your computer and learn how everything fits together to give you the amazing websites that you use every day. Most people know that when we're talking about computers, we're talking about ones and zeros. But where do these ones and zeros come from, and how do they fit together to give you the websites and programs that you use on a daily basis? When we talk about ones and zeros, what we're actually talking about is something called binary. Binary digits are electrical signals that are understood by your computer in a specific language to get you the programs and things that you use every day. It all starts with your computer's keyboard or mouse or barcode scanner, which is called a human interface device. Now that sounds a little bit scary, but when you think about the word, what it actually means is a device to interact with human beings. And that's exactly what a keyboard or mouse does. It allows us to send commands or signals to the computer. If you look closely at the way your keyboard or mouse connects to your computer, you can see that it uses a specific type of port called a USB port. And if you look really closely at these USB ports, you'll notice these little gold connectors that fit into sockets on the computer. These gold connections are just little pieces of copper wire that are designed to make an electrical connection with your keyboard and your computer. All binary digits are used and understood in computers based on modulated electricity. So if I look at this waveform diagram, and a waveform diagram is just basically a map of the electricity that's going back and forth between my computer and my keyboard, you can see here that the pulse changes. It goes from high to low, high to low, high to low. And by changing that pulse, we can send the computer either ones or zeros. Now this is all done on a circuit board in your computer, but basically all it's doing is changing the flow of electricity between your keyboard or your mouse and your computer. If it wants to send a 1, it increases the voltage. If it wants to send a 0, it decreases the voltage. And your computer is just reading these signals and recording the digits as it's needed. Now that we understand a little bit about the electricity behind our computers, let's talk about the internal components. This one is really funny named, and it's called the motherboard. It's called a motherboard because just like your mom, it's designed to keep everything together and keep everyone talking. The motherboard is designed to connect all the components of your computer together, from the hard drive to the USB to your joystick, your printer, whatever. They all connect to the motherboard. And the motherboard's job is to send the information, the electrical signals, back and forth between the components that need it. If you look really closely at the bottom side of your motherboard, you can just see that it's a printed circuit board that's basically working as any other circuit board in your house does. And it's not all that different in computer terms from plugging an electrical device into your home outlet. As I said, all computers are basically electronic components that use electricity to pass information back and forth. And if you look super close at your computer's motherboard, you can see these little gold lines going back and forth between all the components. These gold lines are called buses. Just like a school bus, they're designed to channel the information between one component and another across these little copper wires. That's all they do. They send the ones and zeros to each of the different components that are connected to the motherboard. And remember, when we're talking about computers, everything connects to the motherboard. If the motherboard's designed to keep everything together and keep it communicating, we still need something that decides what the information is and how to interpret it. The computer basically needs a brain, and that's our next component here. It's called the processor. The processor is, as I said, designed to be the brain of the computer. It decides where the information should go, how the ones and zeros gets interpreted, and what information is trying to be accessed. It makes all the decisions for the computer. Without the processor, the computer would be completely useless. And it's magic how these things work together. Processors are commonly designed by a few big companies like Intel and AMD. This is an example of an Intel processor. And what's really interesting about processors is they've gotten significantly faster in the last couple of years. This is a benchmark from a company called Tom's Hardware Guide, which keeps an eye on the speed of processors. A new Core i7 processor from Intel functions at a speed of 982 gigabytes per second. To give you an idea, that's about 250 movies, full-length, motion picture quality, stored on your computer, that the processor is capable of understanding every second. This is a huge number of ones and zeros that are being transmitted back and forth between your processor and your other components inside your computer every second. When we talk about our next component, which is called RAM or memory, most people start to think immediately about how many computer MP3 files or Word documents or pictures you can store on your computer. That's a common misunderstanding, and that's actually talking about our next component, which is called the hard drive. RAM is like a queuing line for the processor. It stores all the information that we'll need to use within the next little while and sends it off to the processor. The reason why we have this is because your computer's hard drive, which is our next component here, is actually very slow. It only sends information at about 700,000 repetitions per minute. And that's actually really slow compared to the RAM, which functions about the same speed as your processor does. So the RAM is a queuing line that keeps track of the information that we're using in the next little while. This is why if you add some more RAM to your computer, it gets a lot faster because it can store more information and it can send things to the processor a lot quickly. When we talk about long-term storage, though, we're talking about our hard drive. And people think that the hard drive is that big piece that fits on your desk. The hard drive is actually a magnetic device that sits inside your computer and is where all your files live when they're not being used. And it works a lot like an old-fashioned record player. You can see these platters here, they're spinning around constantly at a very high rate of speed, and this needle is basically just looking for electrical signals in those magnetic devices and then sending it along. It's not as fast as the RAM, but it's used for long-term storage because it's cheap and very easy to get very high capacity devices. Of course, we know now that computers are always electrical devices, so we would be completely nowhere without some form of electricity to power all of our devices. This is called a power supply, and basically it's designed to supply power. All it does is it takes input from your home outlet and turns it into a modulated signal that the computer can understand. Now that all this hardware stuff is out of the way, we need to talk about how you interact with your computer. And this is done using a specially programmed type of computer program called software in an operating system. Operating systems are developed by computer programmers and are designed to go back and forth between the hardware and the user. And they're designed to give you a graphical representation of what you want to do. The most popular operating system is a product called Microsoft Windows, and that probably sounds a little bit familiar to you. Although Windows is currently the king of the desktop operating system, it's by no means the only one out there. There are other operating systems like Android or Linux or Mac OS that do just as good of a job of taking user input as Microsoft Windows does. Interestingly enough, Android Linux and Macintosh OS are commonly found in other devices like cell phones, tablets, and ATM machines. Now that we know how all of these components fit together, let's look at the whole process. It all starts with our keyboard. We click a button or double-click an icon on our mouse. An electrical signal is sent to the motherboard, which then sends it to the processor, which then asks our RAM to gather iTunes from the hard drive. The RAM says to the hard drive, hey, I need iTunes. And then the hard drive goes and grabs the iTunes program. Then it sends it back through to the RAM, back through to the processor, through the motherboard, and out to your monitor. And that's how you get the programs that you use every day. Computers are complicated pieces of electrical machinery, but by understanding them a little bit better, you can better equip yourself to fix problems when they arise.